Okay, so now let's see if we can try another example on change of the subject of the formula. Now let's try this question out. Make u the subject of the formula. V squared is equal to u squared plus 2as. Now take note of that statement. Make u the subject of the formula. Now, what they mean by making u the subject of the formula is for you to make u to be the unknown that will be standing alone in that equation. At the moment, we have v standing, but they want you to make u to be standing, and u should be standing alone, not with any square, not with anything, just u. Now, in order for us to be able to achieve this, the first thing we need to do is to write the first mathematical statement here. Is v squared is equal to u squared plus 2as. That's v squared is equal to u squared plus 2as. You say that 3 times 2 is 6. It's the same thing as saying 6 is equal to 3 times 6. 3 times 2. If you say 3 times 2 is equal to 6, it's the same thing as saying 6 is equal to 3 times 2. So in this case now, we can say our v squared is equal to u squared plus 2as is u squared plus 2as is equal to v squared. And you are correct. It's the same thing. Okay. So now we have u squared plus 2as is equal to what? V squared. Is the same thing. If you say v squared is equal to u squared plus 2as, it's the same thing as saying that u squared plus 2as is equal to v squared. So now, let's transfer our 2as. Let's transfer our what? 2as. So by transferring our 2as, the sign, that positive sign that you're seeing here belongs to 2as. Remember, here we're having u squared plus 2as is equal to v squared. Now that plus sign is for what? 2as. So now the 2as is going to leave this side and travel all over the equation sign or the equality sign now to what? The other side, where we are having v squared. The 2as will now change its sign. Don't forget, once you cross over, the sign will change from plus to minus or from minus to plus, depending on the present sign. So in this case, the present sign is positive. So the next sign is going to be what? Negative. So by crossing over now, our 2as will now be what? Minus 2as. So our next mathematical statement will now be u squared is equal to v squared minus 2as. Simple. U squared is equal to v squared minus 2as. U squared is equal to v squared minus 2as. Aha! At this point now, the only letter standing here is u. That has been established. But you cannot leave your answer like this. You cannot leave your answer with the u squared standing. No. You've not achieved what they asked you to achieve. They did not say you should make u squared the subject of the formula. They only asked you to make u the subject of the formula. So square will have to give way. Square will have to disappear. Square will have to what? Go away. Now, for square to go, we have to try something out that's very, very interesting in mathematics. And I would like you to note this now. You're not going to use anything like subtraction now. You can't use addition. You can't use division. You can't use multiplication. These 4 basic operations in mathematics cannot be utilized to make the square to disappear. The only cure for square is square roots. So the root sign is the cure. The root sign is what you can use, what you can introduce now to make the square to disappear. So how are we going to achieve this now? So you just go ahead and find the square root of both sides of your equation. You find the square roots of both sides of your equation. Now, if you do that, you're now going to be having the square roots of u square is equal to the square roots of v square minus 2as. Aha! Okay. Now, your square roots will cancel the square on this side, and your u will now be left standing. The square root sign will cancel the square. While here, you can still leave your square roots with your v squared minus 2as. Now, the statement will now be u is equal to the root of v squared minus 2as. I repeat, u is equal to the root of v squared minus 2as. That will now be the final answer. Don't forget, the square roots and the square can actually cancel out in any equation. And the reason why we have to have square root on both sides is because of that golden rule I always remind you, that you must make sure whatever you do to the left-hand side of your equation, you must do also the other side. Thank you so much for your time. Until I come your way again, you have a wonderful day ahead of you. Bye for now.